Hello everyone, I'm Rajasri and today's lecture I'll be discussing parallel connection of SCRs. In this lecture I'll be discussing necessity of parallel connection of SCRs, problems encountered with parallel connection, static equalization as well as dynamic equalization. Firstly, what is the necessity? Why we need to connect the SCRs in parallel? Say I have a voltage rating of 1 kilovolts at which I need to operate the SCRs, and the current handling capability of this is 80 amperes, and I have only one SCR. I have only SCR which carries the current, say 40 amperes. In that case, if I connect this particular 40 amperes SCR to the circuit, in that case it starts carrying 80 amperes and which may ultimately get damaged because the rating of the SCR is only 40 amperes. So that is the reason I'll take another SCR of 40 amperes and then connect these two SCRs in parallel such that together it will be handling the power handling capability of 80 amperes without any damage to the circuit. So as I have already told you in previous video, why not one SCR of 80 amperes? We can manufacture, but in order to meet the various ratings like 5 kiloamperes, 10 kiloamperes, 20 kiloamperes, in that case, we cannot manufacture each SCR separately because it becomes difficult and at the same time cost also increases. So that is the reason we will take number of SCRs, and in order to meet the high current handling capability, we will connect number of SCRs in parallel. Similarly, if we need to increase the voltage rating, we will connect number of SCRs in series and thereby meet the requirement of the string. And what are the problems encountered with parallel connection? Yes, we are connecting number of SCRs in parallel, but what are the problems encountered if we connect the same rating SCRs in parallel? See, there will be certain difference in internal characteristics. Like if you see, this is the current which is flowing, current carrying capability of SCR1, and this is the current handling capability of SCR2. And there is a difference in the current handling capabilities of both the SCRs. Because if you see, if we need to connect two SCRs in parallel, in that case, we need to have overlapping current characteristics. Whereas here there is certain difference in the current characteristics of both the SCRs. And they should also possess equal dynamic characteristics during turn on and turn off time. So these are the two problems which are being encountered with a parallel connection of SCRs. And here, if you see equalizing arrangement, here if the thyristor is carrying two SCRs of each rating 40 amperes are connected in parallel, and if say by chance one SCR it is rated at 40 amperes but it is carrying a current of 45 amperes and the other SCR is carrying only 35 amperes. In that case, the current handling capability of this thyristor is exceeded by 5 amperes. So because of this high current, what happens is, see, temperature increases. And if temperature across this thyristor 1 is increased, in that case, the current will be increased. And because of which, the resistance of this particular thyristor gets reduced. And this is a cumulative process. And further, the resistance will be getting reduced further. And because of which, the temperature increases excessively and device may burn out ultimately. And that should not be happen. So that is the only reason we go for equalizing circuit. Equalizing circuit, we connect the resistance in series with each SCR such that the current which is being carried, if there is any difference, it will be balanced. And the value of the resistance is chosen in such a way that, say, the voltage drop across the thyristor 1 is VT1 and voltage across this particular thyristor 2 is VT2. In that case, the resistance, equivalent value of the resistance which is to be connected in series with the each SCR is equal to, it is given by VT1 minus VT2 divided by I2 minus I1. So that is how we will balance the current flowing through each SCR and avoiding the overcurrent flow through the SCS. And even during turn-off time, as I already told you, the turn-off time of each SCR will be different. And if say n number of SCRs are connected in a string, and here one thyristor 1 has got turn-off time which is turning off late when compared to that of other n-1 SCRs. In that case, the high voltage, that is the whole voltage of the string, will be appeared across this particular thyristor 1, which is turning off late when compared to that of other n-1 SCRs. So because of which, what happens, the high current, the whole current will be carried alone by this n-1 SCRs, and it will be ultimately a burden to this n-1 SCRs. So in that case, the turn on of the thyristor 1 is greater when compared to that of turn on time of thyristor 2. All the currents will be shared by thyristor 1 alone, which may get damaged even in this case. So it is designed, since it is designed only for 40 amperes. And here what we actually do is, the solution for this problem is by connecting the inductor in series with each thyristor. In that case, it provides di by dt protection, that is one thing. And the second thing is, it will balance the currents which are actually flowing through the each thyristor. That is, if inductor 1 is connected, in that case, the current equal and opposite current will be flowing through the inductor 2 as well. Equivalent opposite current will be induced in the inductor 2 as well. In that case, thereby the balance in the current in both the SCRs will be achieved, and thereby we are actually protecting the thyristors from the damage. This is dynamic current sharing. And in the next video, we will be seeing problems on series and parallel connection of SCRs. Thank you.